Hey guys, let me get this music stopped here. Okay, there we go. How's everybody doing tonight? Another Tuesday Night Live. Thanks for being here. And let me just give a shout out. So, getting ready for the turkey rod run. Got the cup car back together. Had to do some modifications to the rear housing to make it a true road race suspension car. Hey Rick, how you doing? Hey, Mike's on. Hey Mike, how you doing? Yeah, that's right. Everybody have a happy Thanksgiving on Thursday. So anyhow, got the front suspension all worked out. Got the cooling system put together. Got the rear end camber situation worked on, and I took the car up to DNR on Monday to do a wheel alignment, get that all set up, and we'll go over that. I didn't get a sheet in the computer. Crap. But did that, and then while I was there, there's another shop up in Riviera Beach that builds custom cars, and they have me do their alignments. And so I went ahead and did 2 of their vehicles, and that's what brought me to tonight's discussion about alignments and chassis. You know, there's a big thing nowadays of everybody buying aftermarket front clips or complete chassis. There's tons of them out there. Roadster Shop's probably one of the most premier names, and from some of the function and fit that I've witnessed with them, they are probably the top of the heap. But you got companies, Street Shop, Art Morrison, Schwartz, Scotty's, just to name a few. There's a gazillion of them out there, and so a lot of these companies do clips like Heights and Martz and some of these other smaller companies. So that's I kind of wanted to talk about that, because there's a lot of stuff that can be screwed up. Chris, hey Chris, how you doing? Total cost involved. That's what Chris has on his car. There's a plethora of suspension and chassis kits out there. So one of the things I wanted to bring up on that, well, let's hold off on that yet. Let's not get going on that conversation. First, let's get caught up with the rest of the week stuff. So tomorrow I leave for Daytona for the Turkey Rod Run. I'm going to display the Cup car in the Living Legends motorsports racing group. We're in the first garage area by coming off turn 4 and in the Cup garages. And if you're up in Daytona, come check us out. I'm hopefully get a little bit of time to go cruise the swap meet. I really love enjoying doing that. My buddy Scott will be there with his Vega. He's got his engine up for sale, engine and transmission, if that's the what somebody's looking for. But it'll be a great time. So I'm going up tomorrow to drop the car off, come home for Thanksgiving dinner on Thursday, and then back up Friday morning, and I'll be there till Sunday. So I will not be there on Thursday, but anybody that's there Friday, Saturday, Sunday, come look me up. So got that done. I got a bunch of stuff done on the T-Type. About almost have the mechanical section of that car done. Unfortunately, the 62 Lincoln came back, the one we talked about last week with starting issues. Starting issues are fine. I didn't drive the car because I didn't know that there was any issues with it. And come to find out, the car has a serious detonation problem. Hang on before I get that. Mike says I'm supposed to make it to the run up there on Saturday. Look at cool, Mike. So yeah, so lost my train of thought. T-type, got all the mechanicals done on that, getting ready to start the electrical portion of that job. Got to put the engine together for the Buick Scott's Skylark. Put that back together and put that in the car next week. The Lincoln, that's what we were talking about. So the Lincoln came in for hard starting, and they never mentioned anything about drivability. So I got the starting situation straightened out. You guys that were on last week we talked about that, showed some videos and stuff. Car left and cranked fine and everything was good. Well, I get a call the next day and it's like, oh, it's spark knocking still. I'm like, okay, I didn't know anything about that. So I took it for, they brought it back up. I took it for a ride and boy, is it knocking bad. So I went around adjusting timing, trying to figure out how I can get this thing to stop knocking, and ended up having to retard the timing even past where it was when it came with the hard starting problem. And guess what? After I did that, got the starting issue again. So the theory on that is that its engine's either been rebuilt, and I mean they have high compression to start with. And as everybody knows, today's fuels are really crappy. So that's probably what it is. Maybe the engine got rebuilt and they shaved the block, and now they raised the compression up even higher. The pistons could be coated with a thick coating of sludge coking, which that'll create hot spots and create knock. So what I did was went ahead and put race gas in it. However, I didn't get a chance to drive it yet. So I'll have to do that tomorrow when I get back from Daytona. And they need that car back for the weekend. And got Scott's truck in the shop. I got to give a shout out to Chuck and Dave. They came up Saturday and replaced all the wood on the door of the car trailer. And you guys know older car trailers, the doors always are the first to rot out. The doors designs are just not very good for keeping water intrusion out. So I got marine pressure treated ply, and we replaced all that wood, and that worked out good. Cam timing could have jumped, Rick. That's a possibility. I didn't get into that. Just the biggest thing I'm thinking is it's just wait, because by retarding timing was only retarding maybe 8-10 degrees, and it's just enough that now it's near zero at cranking. It just doesn't want to start easily. And I don't think that engine had a nylon gear or anything on it, and it doesn't have any engine noise, so it drives really good. I wouldn't think that the cam had jumped, but that is a possibility. If the race gas doesn't fix it, that will be the next step we'll have to go. But a lot of these older cars, doing a 50-50 mix with 110 leaded and unleaded high test does wonders for them. Obviously, lead, it works really well for the valves and the seats. Most of those heads weren't designed for no lead, and so it can pound the seats pretty hard. And the other thing is the race gas and the lead in the race gas will also make the fuel system get some shelf life on it, where you can let the car sit for a couple of months and the gas won't go completely bad right away. So we're going to give that a shot first. That usually seems to have cured this. I've run into this before. But you're right, cam timing could have some type of possibility to that. What I'll have to do first thing would be I can check cam timing, or at least for timing chain slack, by spinning the engine in the order of rotation clockwise to TDC, and then turn the motor backwards and follow the rotor and watch until the rotor moves and count how many degrees the crank moved before the distributor caught up. And that'll give you an indication of how much play there is in the cam chain. And obviously, if it jumped, it would have to have quite a considerable amount of play, probably in a 20-30 degrees of range. But so that was that. We got Chuck's truck in the shop now. Get that back working on that. Bum, bum, bum. Next, not this coming weekend, but the following weekend, which would be December 6th, I'm taking the Cup car up to Sebring for the HSR Pistons and Props race and car show. And we're going to get the car inspected and hopefully get a logbook for the car. So keep making forward progress on that thing, getting that car ready to go on the auction block and get sold. Find somebody that wants to road race a vintage race car, and somebody wants a good deal, because it's cheap money compared to what a normal road race prepped car would cost, and it's a lot of race cars. So so that will be that's what we're going to work on in that. So now I'll go ahead, and now we've burned up a little bit of time, let some people get on the chat. We'll go ahead and talk about tonight's subject: alignments and chassis. They go hand in hand. So a lot of people are doing this now, and it makes a lot of sense. You know, you could take you get a car up in the 70s and the 80s. The chassis are pretty good in them, but any of the cars older than that, the suspension leaves a lot to be desired, especially if you want it to, like a pro touring type deal where you want high-speed cornering and great ride abilities with all the updated shocks and all that stuff. So you can take your 64 Camaro, 64 Nova. Nova's not a good example. That's a unibody. 64 Malibu, or even the Mustangs, even though they're unibody. Any of your older cars, and you can buy a complete chassis that your car is ready to drop on. You'll see on the TV shows, all of them are doing it. Can Dig It and Gas Monkey, and they're buying shops, buying complete chassis. Obviously, Can Dig It does a lot with Roadster Shop. If you watch Iron Resurrection, Joey Martin, he builds a lot of his own chassis, or he'll buy a chassis. And there's nothing that's great. And it's a great way of updating your car, because to take an old chassis, put a stiffening kit in it, buy a complete, like a Ride Tech or a QA1 suspension kit or something. By the time you get done, big brakes and everything, you're going to have, $10,000 wrapped up in it. And for just basically about another $10,000, you can get a completely brand new computer CAD designed chassis. And like with the ones from Roadster Shop, they come with a manual that shows you all the parts and all the pieces and all the work you need to do to make that modification to put it into your car. They just came out with one for 3rd gen Camaro now. They're very, very good chassis. They have 4x4 chassis and IRS, and their Spec 3s, and their so they make very good chassis. And obviously there's other companies out there in the marketplace, and it's one of those things you've really got to look at these things before you purchase them. So here's some pictures from Monday. Let's see here. Okay, so here's the Cup car up on the alignment machine. Doug up at DNR has a great 4-post open beam alignment rack. It's great because it goes in all different directions, and the heads on the alignment rack go up and down and follow the car, so you can get it at almost on the ground, or all the way where you can stand underneath the car and make adjustments, and the alignment machine is working and you can see what's going on. Hey Chuck, how you doing? I see Chris. I don't know if I mentioned you, but yeah, Chris is in. And so there's the car up on the rack. On this type of machine, you have these mirrors. They call them mirrors. Actually, it's a grid of reflectors, and it has the cameras on the alignment machine have infrared, and they zap these reflectors, and how it reads it back. The return gives you your camber and caster and toe and everything. They work really well. Rim clamps work really good on those. Sometimes there are some pitfalls to this because it's taking all four cameras, all four images, and that's how it squares the car and does all that. It's a little tedious because if you move one head or something, you have to reset up the machine and stuff. But once you get the car calibrated, it gives you this screen here, and what this is showing is all four wheels and the start out alignment spec. So you see this is the back of the car. The arrows are pointing towards the front of the car. You can see on the Cup car, the rear end has 0.06 degrees of towing, which is perfect. A negative camber on both sides, although the right side ended up being quite a bit of negative camber. And then, of course, the front hadn't been aligned because as I showed you guys a couple weeks ago, I had to replace the upper suspension mount on one side, and I hadn't aligned it yet. And unfortunately, I forgot to get an image of the final alignment sheet, but I'll get that for you in a minute. This was a truck that I did alignment for those guys. This had, I think it's a Scott's chassis on it. I'm not certain, but it had air ride on it, and this was the position, and it was in its ride position. Kind of got the rear end dragging. Not real happy and cool about that look, but it seems like what everybody likes. I want to skip these next two images because that's something we're going to talk about. Oh, here's the 3/4 angle of the truck. Got the exhaust coming out the side. Really nice. The guys from the shop, because it had no doors and no windows, they drove it over with a helmet on so they could see what was going on. And then this is the last car I aligned for them guys on Monday. 71 Impala Donk with 24-inch Trues and Vogues on it. So, kind of what was set up for the weekend. Of course, you can see the donks have the tail dragging image too. This one, it was really cool. Had a I don't know what size cubic inch engine it was, but large 406 or larger with a supercharger on the 85. Sounded pretty healthy. So, what got me thinking about this was on the truck, and I don't know why, I guess I was running out of time. I didn't get specs on it, but the front end was way out of whack on this thing. So the way the suspension was set up, and I never opened the hood on this truck, but here's the suspension. You can't get to it from the engine bay. And of course, with a 20-inch wheel, you couldn't get it from the wheel area. So I actually had to do the alignment, or check the alignment, pull the wheel off, make my adjustment, put the wheel back on, recalibrate the alignment machine to see where my adjustment was. Now that's a major pain in the rear. But what was even worse is the bad design of this upper A-arm. So there's no adjustments on the lower. All your camber casters on the upper. So you have this upper A-arm, which is not a complete U, and it has like a solid fixed rod end threaded into this arm with a pivot going into this pivot here for the upper control arm mount. This would be your upper control arm bushing. So you can see that this piece is threaded in here, and it's got a through bolt that gives it its angle of attack, I guess. So this is what I wanted to show. So this person, I don't know what they paid for this chassis, but let's just say it was over $15,000. I can guarantee you that. To make an adjustment on this car, you have to take this suspension completely apart and adjust these links in and out. Pretty much guess how much you want to go, and then put it back together. Well, here's the second problem. because this A-arm, if you go back to this image, you can see that they aren't square. So as you run those out to gain a positive camber, the A-arm is getting wider. So what you have to do then is loosen these little pinch bolts, unscrew these control arm pivot bolts out so that you can adjust everything, and then run everything in tight and bind everything up. Very, very, very bad design. Plus the fact that this was a 3-hour wheel alignment, and I couldn't even get the specs to what I would consider really good specs. It came in with almost 2 degrees negative camber, so the upper control arms, the top of the tires were in 2 degrees. I got it to 0.5, but these things were very, very stiff when I was all done. So just very, very poor design. So let me see, I got some more pictures here for you guys I wanted to show you. So here's one design of a this was a front clip from I think this was I don't remember which one this was, but anyway, you can see they have Corvette A-arms on this thing, and they have camber bolts there where you put your shims. So it's not going to be super easy to do, but at least it's doable. You can rock your A-arm, your bushings in and out to get caster changes and camber changes. So it's much better than the chassis was under the truck. Here's a Ride Tech chassis. Not Ride Tech. Wow, just totally lost my train of thought. This is a Roadster Shop chassis, and you see they put eccentrics. Now that is the best of the world. Whenever you have a vehicle with an eccentric arm, now you just loosen the pinch and rotate the eccentric to where you get to gain the camber gain you want, and that gets you where you need to go. Now you can swing your A-arm, and you can get the suspension alignment wherever you want. It's real easy. You don't have to take anything apart. It's just the best design you can go. Yeah, I see Rick says, yeah, freaking engineers, right? But this is important. You know, this and I am totally bad with names right now. Roadster Shop. This Roadster Shop chassis, powder coated with the brakes and everything, is going to be darn near $20,000. And to get something you couldn't align would be crazy. At least they do their engineering, their due diligence, and you know, it will work great. You can see here the way they boxed all the rears and stuff to fit around the floors and stuff. I don't know what vehicle this was for, but very, very well thought out and engineered chassis. This one here, I believe, I think this is a Schwartz. Again, they use Corvette style mounting, so you've got your shims up here. But not bad. I don't mind shims. A lot of your productions of 60s and 70s cars all use shims, so there's nothing wrong with that. But let me see. I got some more stuff here. What's this one here? So here's another one that's poorly engineered. This is a Martz front clip for 49 to 54 GM vehicles, and you can see they don't have eccentrics. No, they do have eccentrics. I'm sorry, I take that back. I saw the bushings here and thought this was you had to turn them. At least this upper arm looks square, so if you did have to adjust it that way, you could get where you need to go. So actually, I'm going to take it back. This is even a better design, because if you run out of eccentric, you could always take the upper control arm out, lengthen that threaded adjuster there, and get you back in spec. So that's a good design there. And this is another Roadster shop. This is their stock spec chassis. Again, they got the eccentrics in there so you can adjust the suspension wherever you need, alignment wherever you need to go. So these are things you want to look at before you purchase a chassis. How is the alignment procedures done on that vehicle? If you have to unbolt the A-arm from the vehicle to make an adjustment, that is not an alignment, a chassis that you want to get. Let's see. I got some stuff from a long time ago, and we can go through this stuff. So when you're gonna, because you need to have the vehicle serviceable so you can do wheel alignments. That is a must. If you want to do your own alignments, it's easy. You can buy very good equipment. We'll go over this stuff. This is stuff that we talked about probably about 30 episodes ago, 40 episodes ago. But here's some cheap alignment tools you can buy. This is a Fast Track from Specialty Design Company, SPC. And this just goes on, it's got like a rim clamp, goes on your rim. You read your camber and caster off of the bubble gauge there. And there's nothing wrong with the bubble gauge because even your fancy alignment machines, they're all going off of a level. It's just whether it's a digital level or a bubble, but still all the same technology. This is a long acre, which is kind of what the old school stuff used to do. This would go, you take your grease cap off your front end, and this would go into your on your hub of the front of your vehicle. Now, of course, if you have like a Willwood or something like that with an aluminum hub, this kind of gauge will not work because you need to have a steel hub. But very inexpensive. You can get these for under $100. That's just showing using lasers how to do it. You can measure from the bottom and the top of the wheel and figure that out. You can use your front one for thrust angle. You would need some type of turntable so you can do you can swing the tire for caster. So you'd have to get some kind of turntable. These are production turntables that you can buy aftermarket, but I've seen people use layers of linoleum tile or pieces of Lexan or aluminum and put dry lube between the plates so they would slip. And toe adjustments, very simple. Toe is just a couple plates and some tape measures. This is one that you can actually purchase that is adjustable for your width and your height, so you can get around suspension components. Our lowered vehicles, exhaust and everything hang down real low, so you need to better get your measurements as close to the ground as possible, so you can get. But you can buy these or even build these. I have a set of toe plates I made. You can. There's ones here where you can scribe the tire and then measure the scribe. That's good for allowing for run out if you have run out in your wheels. Kind of something you could do at the track. And this is the same type deal where it's just measuring off the front and the back of the tire, and you can measure your toe. One of the things that's always important when you're doing wheel alignments is put the driver's weight in the car. So you can use bags of sand, lead weights, dumbbells, whatever you have laying around, but that way somebody doesn't have to sit in the car for a couple hours while you're doing your alignment. This is just a level you've wanted to check your the ground, and you could go ahead and put that on your rotor and stuff like that, and you could get by with an alignment like that. Here they're showing how to make your own turntables. So they got a little bit of oil on the first plate, and the second plate they've got their scribe lines at 20 degrees. Because that's what you want to do. You want to clock your wheel, turn it in. Turn it out 20 degrees. Set your caster gauge at 0, then swing it to 20 degrees turned in, and then that gauge will show you the inclination of your ball joints, which is what caster is. They're using linoleum with some, I guess it was some salt. Use that as a bearing agent. And here's another one of those tools where you can grab the rim clamp, and they're using a digital level. And you can see he's got his little makeshift turntables on the bottom. So that's the equipment you would want to need. But my main thrust of this conversation was just be careful out there when you go to buy a chassis, and you can't do alignment easy. So let's see what these are. Okay, so here's if you go back and look at the chassis dynamics, I think it was 3 episodes on the live show. Here's some of the stuff we were showing you. So here's my camber plates toe plates I have. It's just a piece of a 1/4-inch aluminum plate, and it's probably about 20 inches long, and then I've got holes drilled in it for the tape measures to go through. And you can see the tape measures go across from side to side. And then so that's, you set it up on one side, and you can see I've got the plate angled. That's because the tire is always going to have a bulge at the bottom, so you don't want to lay your toe plate dead against the tire. You want it kind of cocked so you're grabbing the wheel, and you can see in this picture at almost midway. And then if you go back to the other picture, and you can see, then you just read the front to back difference. So if the front is 70 and the back is 70 1/8, you've got an 1/8 inch toe in. If as long as the front tape measure is narrower than the rear, it's toe in. If the front tape measure is wider, then you're toed out. So you can see how they're angled, and you can read the gauges like that. Here's my SPC gauge. You can see there's the bubble. One side is for camber, one side is for caster. In this position, because the wheel is straight, we're reading camber. And at this point, the car had a 1 degree negative camber, so we would have to either pull the on a race car, you pull the lower control arm in because it's the upper is fixed, and then you make your adjustment. And these are accessories you can buy for the SPC, where these actually go down, these arms go out, and they become toe bars, so you can measure toe. Just the other side, actually. So there, we're actually doing a camber sweep. The wheels turned in. You can see at the edge of the gauge, they've got 20 degree built in the edge of the gauge. So it's on that part of the gauge is parallel with the lift, so that tells us we're at 20 degrees. I have a couple little layers of aluminum plates under the tires, and you can see I've zeroed out the gauge. That was with it done. Did I get? Maybe I did not get the. Oh, I'm sorry. This was caster. So it wasn't 1 degree negative camber. It was 6 degrees of caster. Sorry, I should have looked at these slides first. So let's go back over that again. So first we want to set camber. So we have the wheel parallel, straight forward, and we have 0 on our camber, so our camber is correct. Now, of course, if you're doing autocross or road racing, you're going to want a different alignment spec, but for drag racing and for maximum tire wear, you want 0 for your camber. You want the tire to sit square. And the reason on when you turn corners is there is a camber gain in the suspension. Your upper A-arm is shorter than your lower A-arm, so as the car goes through bounce, especially compression, the tire is going to gain in negative camber. So you want to take all that into consideration. And if you go back to the chassis dynamics videos live show, I showed how to scale on paper your roll centers, and that then you can plot that stuff and then do bump on the chassis and see how your camber gains and stuff, and that'll give you a really quick and dirty way of getting a guesstimation of where you want your alignment. The finite way of doing it is tire temps. You go to the track, you run the car through the course, you can pull off the track as quickly as possible, and you read tire temps. And the goal is, no matter what kind of racing you're doing, you want to get the most even tire temps across the inside, outside, and center of your tire. That's how, when that's even, then you have your camber set properly. So here's our camber on this drag car that I did on this demonstration. So then we turn the tire in. So the back of the tire closest to the firewall is in, the front of the tire is out. We set it at 20 degrees, and we zero on this side of the gauge, our caster gauge. And there's the tire turned in. There's the tire turned out, or I guess that maybe you want to call that turn in, turn out, depending on which side of the car you're working on. But the front of the tires is in, the back of the tire is out, and we're back at our 20 degrees. So there's our 20 degree, even with our lift again. And now you can read the caster side, and it has 6 degrees positive caster. And that's what you always want to get whenever you're doing your alignment. You always remember, so your camber is going to be done by tire temps. Caster is your tire return to center. So when you're going through the turn, you let go of the wheel, and it returns to center. There's a saying in racing that caster is faster because the car will return center faster. And it just makes the car much better handling. In drag racing, because you're going down the track with the suspension droop, the chassis up and the suspension's down. And as the car settles, you always want to get the most caster. So, and that works for all cars. So, one of the things I always say is if the car goes, say, 0 to 70, 80 miles an hour, you can get away with 3 degrees of caster, and the car will drive fine. It'll drive great. As you increase speed, you have to increase caster. So, if the car goes 125 miles an hour, I'd want 4 degrees or more of caster. If it goes 150 miles an hour in the quarter, or 150 mile an hour terminal speed, then you want about 5 or 6 degrees of caster. And as you keep increasing your speed, you want to keep increasing the caster. It's going to give the driver a much better feel on the steering wheel, and won't get the car feeling uneasy or out of control at high speed. So if you ever been to a drag race, or you watch drag racing on TV, and you see funny cars and dragsters turning in the staging lanes, getting ready to pull into the burnout box, and they're making that hard 90-degree turn from the staging lanes to the drag strip, you'll see that the tires lean way over, and that's because they run an excessive amount of caster. On a dragster or funny car that are running 330 miles an hour or up to, those cars could have as much as 15, 16 degrees of caster in. So just makes the car much better to handle. So that's an important factor. Again, if you're going to buy a chassis from somebody, what are your alignments? What are your alignment specs on this chassis? What are the what's the range that your chassis is designed for? The last thing you want to do is buy a chassis that can only get plus or minus 1 degree of camber, and can only get 5 degrees of caster. Well, if that's gonna be a high-speed car, or you're gonna use it for autocross or track attack or road racing, that's not enough caster, not enough camber adjustment for that car. You're gonna have to make further adjustments. It's one of the things we run into all the time when we're taking an OEM car. Vethawk is a prime example. It's got a 89 Corvette chassis in there. That Corvette chassis, which on that particular model has shims on the top, it can only get without having an absorbent. Well, to get negative camber, you take all your shims out. You take all the shims out of the frame without making any modifications to the frame, you can barely get 2 degrees of negative camber. So for autocross, that's not enough. So then what you have to do is you have to reposition the lower control arm so it pushes the control arm out, and that gets you back in the range on your upper shims where you've got an adjustment. And then again, caster. If the car's if you're gonna go on road courses and do stuff like that, you really want to have that as much caster as you can get in to have that good high-speed drive. I see Ryan's in. Hey, Ryan, late as usual. Welding on the Capri. Oh, on your son's car. Awesome. Hopefully he's helping you. Chris says caster is when the tire is leaning front or back. Right. So caster, the easy way to visualize caster is the forks on a bicycle or forks on a motorcycle. So if you look at the forks on a motorcycle, you've got your get my hand in the camera here. You got your handlebar here and your axle on the wheel down here. Well, on a factory bike, they're like this. Not much caster. So they drive good, but they don't handle real good high speed. So then as you bring them out, they get farther out like this, they get really good. Now, obviously, a chopper gets way out, and then it goes the other way. Now, the steering wants to flop on you and stuff like that. Don't think about that. We're only talking about 0 to maybe 10 degrees in a door car. All your strut front-end race cars, drag cars, usually come between 8 and 12 degrees of caster built into them. Ryan says he's scared of the welder, but he's in the shop. All right, well, cool. I mean, everything takes time. Right, and Mike says in motorcycles they call it rake. It's the front rake of the rake of the bike. But that was one of the things back when I was a young guy. We used to race drag race bikes, and that would be the first thing we'd do. We'd take that street bike and we'd cut the upper neck, the upper tube of the neck, and pull the fork pivot back about 1/4 to a 1/2 inch, which would push the front axle out about 2 to 3 inches. Night and day the way the bike rode at high speed. Very, very well mannered bike when you made that rake change. So on a car, you're going to have, if you have a strut front end, it's going to be your pivot. Where's my hand? There it is. Pivot from the upper strut to your lower ball joint. That's going to be your caster. Now, like on a Mustang, the strut goes forward and then attaches to the spindle, and then so you have to. It's going to be an invisible line. You can't just go off of your strut as being the legit caster line. And then if you have upper and lower control arms, or you have a kingpin, like if you have a straight axle or something like that, it is that upper and lower angle from your ball joints or from the top and bottom of your kingpin. That is your caster. So a lot of times you can put a little angle finder on your spindle, and you can read your caster. Even if it's not 100% right, if you're going to make a caster change, at least you could read it and then just make a 1/2 degree change and see how the car drives. So, but these are just important things I wanted to put across to you guys. I know Joe wants to put a frame underneath his 64 Corvette, which we're going to do a roadster shop. And I've talked to other guys about doing some chassis underneath their cars. It just makes sense that you, one, obviously price point is important, but you want to make sure that that they've got the proper engineering in the suspension. Now, we're not even getting into roll center, so that's a prime example where I even got burnt. When I had my 50 Chevy, I bought a C5 Corvette kit for the front suspension. So you replace the front frame with this aftermarket frame that on that car, the subframe bolts in, and it takes all C5 Corvette components. And I asked the manufacturer 3 consecutive times, what's the alignment specs, what's the proper ride height, what size, what's the coilover that requires it, the proper ride height, and what is your roll center. And like I said earlier, when you go back to those chassis dynamic podcasts, I didn't catch the numbers. I should have done that. But those are really important. Roll center is really important when you're getting into turning. Drag racing is not as much important bump steer is the only thing you're really concerned there. But at the end of the day, they wouldn't give me any of that information because they were accusing me of trying to steal the information to build my own suspension. I'm like, I'm purchasing it, so why would that be stealing? But whatever. I ended up buying it anyway, and sure enough, it was a hot mess. And I fixed some of it. I didn't fix all of it. I just kind of gave up on it. But I made it to where it was pretty respectable. It was definitely a good street vehicle. But as far as I did have to relocate some stuff, and I relocated the upper control arms, and had to fix the bump steer in it. But I got it working pretty good. So that's the main thrust of all this, is that, you know, if you don't want to have to spend more money after you buy something, then try to do your due diligence and get the right stuff. Something else that drives me crazy on these chassis, let me advance these pictures. So again, this is a drag car that I showed in the videos in the other podcast, but you can see on your rear trailing arms, obviously they're adjustable for angle. That's one thing that is very handy to have, so that way you're going to get the proper load on the rear axle when you're driving. So like if you have a 4-bar suspension and the top bars are really close to the center of the axle housing here, and they're parallel, that car is not going to have traction. It's going to spin the tires all the time. It's just not the right geometry. You want angled bars because you want an instant center. You can go back over those other podcasts and see those where I explained all that stuff. But what I brought this picture up for is I see a lot of cars that have 4-link factory suspension in the back, or aftermarket chassis that's got a 4-link suspension in the back, triangulated or parallel, it doesn't matter. And they put one arm will be fixed, one arm is adjustable. Well, now you need to know whenever you want to square the rear of your car that you have to take that arm out of the car, at least one end of it, to make your adjustment and put it back in. Whereas this bar having adjustment turnbuckles on both sides, all you gotta do is loosen your jam nuts, turn this bar. You don't have to disassemble anything. 5-second quick adjustment. So these are the things you really want to look at when you're anticipating buying a new suspension, because you can get yourself in a lot of issues with that stuff. So anyhow, so that was my big thing I wanted to discuss tonight, because I ended up spending a long time adjusting that pickup truck to get the alignment done. I think it ended up costing them about 4 hours. So where a normal custom alignment, I normally charge between $150 and $300. That alignment was $750. So all because poor design in the chassis. So, you know, it's kind of a double whammy. They ended up spending a lot of money for the chassis, and then ended up spending a lot of money for the alignment. And the alignment wasn't even perfect when it was done. I had to take some creative leeways there, because I couldn't get what it needed. The upper A-arms actually need to be modified to get the alignment where it should be. So, you know, you just have to make the calls as it is. But again, to spend $20,000 and have an alignment that's it's got compromises made in it, it's not worth it. That's not why you want to spend that money to put a new chassis or a new clip or any of that in your car. You want to make sure that it has what you're looking for. So that was that. Let me see here. I'm gonna look real quick, see if I can get you guys the. Yeah, it's going to take too long to look for that. I was going to give you the podcast numbers of that, but I'll put it in the comments. I'll do that. But yeah, we got everything else pretty much going. Excuse me. And the little iced tea got dried there. So anyway, we got everything set up for the rod run. That's great. We'll get that going. I'll get back and get the wiring harness done and get you some more pictures on the T-type. Hey John, how you doing? Happy Thanksgiving. Yeah, we just did a big discussion on aftermarket chassis and suspensions and clips, so you have to replay on that. Yeah, I'll show you guys some stuff next week on the T-type, and I'll have Scott's car here. I won't have anything because I only have Monday to work on, but we'll get Scott Skylark in here, and that'll be in upcoming shows, getting the motor put back together on that. That thing was a disaster. We had somebody made a flex plate. Well, it didn't make a flex plate. Somebody made a conversion from a stick shift to an automatic, and they used the standard flywheel and then tried to hang a converter off of that, and didn't have the right recesses, or there were no recesses to center any of the components. It was all just using the 6 crankshaft bolts. So every time you took the crankshaft loose, everything kind of got out of alignment. They did that because they figured the motor had been balanced and they didn't want to mess with the balancing. I ended up getting a custom flex plate made for the vehicle, and come to find out, I took the engine apart because I knew we were going to have to check balance. Come to find out, the motor wasn't even balanced right to start with the stick shift flywheel on it. So, you know, that's things that happen when you buy used engines. So, Chris says, how do you calibrate spring rate? So, thank you, Rick. So the episodes 39 through 42 are where the chassis dynamics are. So tonight we just touched on the problems and issues with aftermarket chassis, or possibilities of aftermarket chassis and what they can cause in your alignments. And then if you want to go into the dynamics of how you figure out the alignment and rear suspension dynamics and stuff like that, those are the episodes 39, 40, 41, 42. There's actually 4 episodes that we broke that all down. So to answer Chris's question, spring rates. So first you need to get the corner weights of your vehicle. So you got to put the car on a scale. If you don't have 4 scales, like a set of racing scales, you can cheat by just weighing the front of the car and then weighing the back of the car. That'll give you a kind of rough estimate of where your corners, what the front and rear weights are. Then what you need to do it accurately, you need to deduct all the weight of the suspension. So your tire, your brakes, that would be straight weight. Then your A-arms are half of the weight because they're bolted to the chassis and to the suspension. And then your shock is another 50-50. It is bolted to both. Tie rod end links and stuff like that. A lot of that stuff you can kind of estimate. There are some calculators out there. QA1 and RideTech both have calculators where they kind of give you rough ideas of what suspension components weigh. On your rear end, if it's a straight axle, your complete rear axle and wheels, tires, and brakes are all going to be at 100% of the weight, and then your 4-link or leaf springs are half the weight because they're tied to the car again. So if you get your corner weight, so let's say your front of the car weighs 1,500 pounds, and you're working on the front, and you got a tubular A-arms and lightweight spindles, so your unsprung weight, in other words, the springs aren't affecting this weight is on the ground. So let's just say it would be 200 pounds of all the components combined. So you would take that 1,500, deduct the 200, so your sprung weight then becomes 1,300 pounds. All right, So now, if your shocks are straight up and down, you can take that 1,300 pounds, look on a spring chart, and wait a minute, there's one other thing you have to look at. You have to look at spring ratio, spring ratio. So from your ball joint to your lower control arm, the spring is going to mount in that lower A-arm somewhere. Either it's a spring in the spring pocket, a coilover by the coil shock. So you have to take that ratio, and on these spring calculator charts, like I said on QA1 and on Ride Tech, they break this all down. Actually, AFCO is another one. They have all that on there too. So there's a formula for figuring out where your spring is. So obviously, the closer your spring is to the chassis side of the lower control arm bushing, the heavier the spring is going to have to be. The closer it is to the ball joint, the lighter the spring will be, because it's closer. It's not fighting. It's got the chassis right at the tire. On a strut, if your spring is out there, it's out there. You got to still calculate that ratio. Then the last thing you have to figure out is the angle of the shock. As the shock or the spring leans in on an angle, that also changes the spring angle. So let's just say your spring on 1,300 pound sprung car, you got 200 pounds of unsprung, and your spring is almost at the ball joint, say like a strut, like in a Mustang. Ryan's working on a Capri, Fox body. So there you go. So now your spring is as close to the ball joint as it can get. It's on the strut if you have a coilover setup. So typically on those, with about that weight, you'd probably put about a 200 pound spring, 225, maybe max 250. If you had a big block iron head, you might have to go like to a 350. Now, if you're on an A-arm and it's a couple inches in, like on a GM where it's near center in between the chassis mount and the ball joint, the factory spring is going to be straight up and down pretty much. So it would probably take, for that same vehicle, it's probably going to take about a 350, 400 pound spring, because it's farther in, so it has to have more spring rate to work, because it's losing its leverage because it's closer to the chassis pivot point. Now, if you angle it, where you're putting the shock on a coilover, you got to take that angle in, and that's going to even make the spring become even heavier, because now you're losing that straight up and down leverage. Now you're on an angle, so you're creating more leverage against the spring to make it weaker. So you'd have to run probably about another 50 pounds heavier. And same thing on the rear of the car. Now, the rear of the car, typically your springs, if you're coilover, are going to be behind the axle. If it's a factory coil spring, it's usually like right on the axle. So if they're straight up and down, it's going to be the same. It's going to be pretty much one for one. You just got to figure out what springs are going to be right for your vehicle. So let's just go back to that 1,500 pound rear suspension weight. We're going to have, let's say we got a 9-inch rear end with Willwood brakes and regular wheels and stuff, but an iron chunk in there, that's going to be about 300 pounds. And then you'll take whatever suspension components and half those. So let's just say you're going to be 375 pounds of sprung weight on the back, unsprung weight on the back of the car. So you would take your 1,500 pounds, subtract the 375. That's going to leave you with 1,125 of sprung weight. Now on a drag car where you're going to have an IC forward and the car is going to have squat, whether it's a drag car or any suspension car, if it's going to have squat, so when you put the torque of the engine is going to make the suspension squat the weight of the car onto the tires to drive the tires into the ground for traction. You're going to have to run a spring appropriate for that. So like in a drag car, we want the car to be able to squat as hard as it can. So we would probably run like 120, 130 pound spring on that 1125. If it was going to be a daily driver street car, we'd probably run about a 200 pound spring on that, because we want a little bit more spring to absorb we don't want to be bottoming out the suspension all the time. Drag car, you're only going one way straight. You're not going over bumps, so you can afford to have that full travel. Now again, if the springs are on an angle, that's going to increase your spring leverage, and you have to do the math calculations to figure that out. You'd probably have to go to a 200-pound spring if they're like 70 degrees of angle. That's why you always want to get your springs as much straight up and down as you can. That's why you'll see a lot of these cars now, these high-end cars, going to cantilever, because now the cantilever, the spring is straight in between its two mounting points, and then it has a leverage arm that goes, a lever arm, a pivot, and a lever arm that goes down to the suspension, and that way that lever arm can have the big angle on it, but your shock and spring are going to be straight. So there's a lot more math that goes into that type of a suspension, but it is really cool to look at that and see how that all works. So use those charts. I will tell you that typically the charts I found on QA1, even Ride Tech, they usually will skew heavier. So like I was just talking to somebody today. They bought a QA1 kit for their Chevelle, and the QA1 kit came with a 350-pound spring, and he was concerned, hey, I've got a big block. Is that going to be too soft? I think it's going to be too soft. I think they say he needs a 450. Well, the couple things there to note is, one, he's got a big block, but it is a Gen 6, so it's a late model thin wall block. Then aluminum cylinder heads and headers, no cast iron, aluminum components on the front of the motor. It's not going to be as heavy as a regular big block. So 450s, I know, are going to be way too much spring for it. And he wants a comfortable ride, and he wants to be able to lower it. Well, the problem with the 450 spring is you would end up with the spring at the bottom of the adjusting cup, and now you can't lower the car anymore because the spring is so stiff. You had to use all the travel of the shock to get the car lowered. So go to a 350 spring. Now you can run the spring seat up on the shock to get your ride height where you want it, and you have a little bit more stored energy in the spring because now there's some travel. One of the things about spring rate is springs are rated at 1 inch of compression. So a 450-pound spring, you put it into a spring tester, you get your fixed height where the spring is in its neutral point. It's not applying any pressure yet, but it's not free. And then you compress it 1 inch, and then the gauge will tell you how much spring pressure that spring has. Then what you want to do is figure out if it's a linear spring or a non-linear spring, and then you collapse the spring another inch. Well, on that second inch, it should double. So if it's a 450-pound spring at 1 inch, it should be 900 pounds at 2 inches, and so on and so forth. As you keep compressing the spring, it's going to keep doubling. Now, if you have a variable rate spring, non-linear, it won't work the same way. You'll probably get like 450 on the first inch. The second inch may go to 550. The third inch may go to 650 or 750. And those are the springs you see where the winding is different. It's close together at one section, far away from the other section. And the theory there is to try to get a better ride. But I like a linear spring because it's gonna be more consistent in what's going on with the vehicle. It helps with your shock valving and stuff like that. Chris, is that? Thanks. I'll leave it for the professionals. Yeah, I mean, it's a little bit. You'll have to check out the charts. It's not that involved once you look at the math. It's very simple math. Just have to divide one into the other, and then that gives you a ratio, a percentage. Your spring angle, shock angle, you can do with a protractor, or a angle finder, and just put it on there, and it'll tell you the angle. So it works out well. Of course, in a road race, autocross, you're going to run a lot stiffer spring because we're going to give up some ride comfort. So like on my 50 Chevy, I would have normally ran about it because that spring was on a very steep angle. The way they designed it was a pretty poor design. It was about a 80-degree angle on the shocks. So on that, I had to run a 450 for comfort. But because I was going to autocross, I ended up running 600s on it because I wanted the car to be stiff and try to keep it level and flat in the corners. As long as you're not bouncing the car off the ground when you go over bumps, those are the things you have to take into consideration. But to just go back on the theme tonight, if you're going to buy a chassis or a clip or anything like that, find out all this information. If the manufacturer's got any salt on the earth, they're going to be able to give you, hey, this is what we did with this package. These are the springs we ran. These are the shocks we ran. Going back to shocks, even though it's not anything of alignment, but if you're buying shocks, you're buying a chassis, spend the money for the extra adjuster. So you can buy a shock that's non-valve adjustable, externally adjustable. They're good, but if you don't like the ride, you either have to take the shock apart and have it revalved. Some shocks you can collapse and click. That's kind of old school Lakewood stuff. And some Coney stuff, I think, did that. You don't see that stuff too much anymore. Then you go to a single adjustable, and you're like, well, I can get that single adjustable, and that'll give me some adjustment. It does give you some adjustment, but typically it's going to give you compression with a variance of rebound. So compression is the squat, how fast the shock goes together. When you hit a bump, it's got to collapse or compress, and then when you come off the bump, it's got to rebound. It's got to push the tire back to the ground, so the tire follows the curvature of the ground. When you have a single adjustable, you're going to get a lot more. You're going to get like, say, 60% adjustability out of the compression, or let's just say 100% of adjustment in the compression. You're only getting about 50% of rebound. So, and you're not going to be able to differentiate the two. It's just going to be whatever you do the compression, it's already got a fixed location for rebound. So it's okay for a street car, but if you really want to dial the car in and really make it ride nice, buy a double adjustable. They're not that much more in the grand scheme of things. And now you have a separate compression and rebound. And I have found where you have to speed up the rebound but slow down the compression to make the car ride nice down the road. So, and then you just can fine-tune the vehicle to your ride liking. And the other thing is you can record the clicks that you set them on, and you can have a highway cruising chassis set up, and then you can also adjust the shock clicks and have an autocross or a road course or a drag strip setting to where the car is going to do its best in that scenario where it may not ride as good on a highway. So it just makes it really good. And if you're going all out racing, get the four-way adjustable, which then has the nitrogen cartridge with a high-speed adjustment on that. And then you got way more adjustment than 90% of people know how to do. But I just wanted to bring that up. I ended up wasting my whole day aligning those three vehicles. Obviously, the Cup car is shim and eccentrics, very easy to align. The Donk had QA1 suspension, which has been modified for the ride height of a Donk, and it uses factory shims. Very easy. I aligned that car in an hour and a half, but the truck took a good portion of the day. I started before lunch, and I ended up almost 3 o'clock before I finished that job. And it only allowed me 2 hours to rush through the Donk alignment. So, and it didn't need to be that way. That was just poor engineering on the person that designed that suspension. So, just want to warn you guys, it's very hard for us to earn the kind of money it takes to buy these aftermarket chassis for our hot rods. Our hobby is a little bit of an expensive hobby, and to end up spending hard-earned money and get an inferior product is just no good. So, just don't buy that brand because it's got a good name. Do your due diligence. Make sure that they have the adjustability that you're looking for. And then if you are, doing your own alignment, see if you think you can handle that on the way that they have it designed. Or if you're going to use an alignment shop, take the pictures to the alignment guy and say, hey, is this going to be a major pain or is this something you deal with? And, if it's a typical shim front end or something, he's going to say, oh, I deal with that every day. Not a big deal. I keep the shims in stock. Easy peasy. And then, you could look at like that truck and go, oh, my goodness, that's going to take forever to align that thing. Stay away from it. And it's going to save yourself time and aggravation and a waste of money. So that's it. I'll get off my soapbox. That really irked me, as you can tell. And it's a shame because somebody spent a lot of money on that thing. So anyway, so that's what I had tonight. I'm going to get a bunch of videos, pictures, I hope, from the rod run. Again, like I said, if anybody's going to be there, come look me up. And we'll go from there. We'll be live again next Tuesday. I appreciate everybody coming out. I seen Rick's got his second block to the machine shop. Hopefully they're going to be good on their second block. I was talking to Chris earlier today. He pulled his engine and transmission out to put a new clutch in it. He called me this afternoon, and we were deathly afraid that maybe one of the discs was in backwards on the dual disc, but he texted me and said he got it straightened out, so it was just getting the clutch bled properly. Glad to hear that, Chris. I know you weren't looking forward to pulling that thing all back apart, but glad you got it straightened out. So hope Ryan and his son are having a good time working on that Capri. We'll have to get some pictures of it sometime. And I think that's about all we have for this week. So everybody have a great Thanksgiving, and enjoy. If you got some time off, enjoy your time off. Enjoy your family and friends, and we'll see everybody next week. It's going to be a short week, mainly just going to be at the rod run, so won't have a whole lot for next week's show except for the rod run. So tune in for that, and we'll get back on tech stuff and go from there. Hit the like button, do the subscribe and all that happy stuff, and have a great weekend, holiday, and I'll talk to you all later. See ya!